Hello Cloud Gurus and welcome to this lecture. And this lecture is just our section summary with all of our exam tips for this section of the course. So let's get started. So starting off with Athena, just remember what Athena is and what it allows you to do. So it allows you to run standard SQL queries on files you have stored in S3. You point it to your files in S3 and it allows you to run standard SQL queries against the file. And one of the most common use cases for Athena is to analyze CloudTrail logs. And if you remember in the lab, that's exactly what we configured. So we created a CloudTrail to log all of the API activity in our account. The logs were stored in S3 and we used Athena to run SQL queries against the logs. And remember, Athena is completely serverless. So it's not a database, but it does give you a database style interface into your data that is stored in S3. Moving on to Macie, once again, you just need to remember what it is and what it allows you to do. So it uses AI to analyze data in S3 and helps you to identify personally identifiable information, or PI. So it's a security service which uses artificial intelligence, which allows you to analyze your data to identify any personally identifiable information. So think sensitive personal data like passport numbers, driving license numbers, credit card numbers, date of birth, etc. And it can also be used to analyze CloudTrail logs for suspicious API activity. It includes dashboards, reports, and alerting as well. And it's great for PCI DSS compliance and preventing identity theft. Moving on to Guard Duty. Remember, Guard Duty is basically like a security guard or a police officer, keeping an eye on your account and alerting you to any untoward behavior, particularly in relation to your EC2 instances. So it uses artificial intelligence to learn what normal behavior looks like in your account and to alert you of any abnormal or malicious behavior. And when you first configure Guard Duty, it spends the first 7 to 14 days creating a baseline, so building up a picture of what is normal in your account. And then once it's active, it will report on abnormal activity based on what it already knows about your own account. It keeps a record of known malicious domains using external feeds from third parties, and you can also add your own threat list, so your own set of IP addresses that you would like Guard Duty to report on if it spots any network interaction between your EC2 instances and the IP addresses listed in your threat list. And if you remember in the lab, we generated some sample Guard Duty findings, and the kind of thing we saw Guard Duty reporting on was things like if your instance is trying to interact with an IP address range or a domain name that is known to be associated with malicious activity. For example, a domain associated with Bitcoin or phishing, and it will also report on evidence of compromised instances as well. So things like port scanning, failed logins, and that kind of thing as well. Findings appear in the Guard Duty dashboard as well as CloudWatch events, and you can actually use CloudWatch events to trigger a Lambda function to address a threat. So you could create a Lambda function to modify a security group or network access control list in order to isolate an instance which Guard Duty is showing to be compromised. Moving on to Secrets Manager. So Secrets Manager can be used to securely store your application secrets. So think database credentials, API keys, SSH keys, and passwords. And it is mainly used for database credentials, so the username and password of the super user account for your database. But you can really use it for any secret that can be stored as a key value pair. Applications can then access the secret using the Secrets Manager API, and this means that you don't need to embed database passwords or credentials within your application code. Rotating the credentials is super easy, but do be careful because once it's enabled, Secrets Manager will rotate the credentials immediately. And if any of your application instances are still using embedded credentials, then those embedded credentials will then be out of date, and this will break your application. So do make sure that all of your application instances are configured to use Secrets Manager before you enable credential rotation. Moving on to SES, or Simple Email Service. Remember, this is a cloud-based email service allowing email notifications from your applications. And your applications can access SES using the standard SMTP interface or the SES API. And if you want your EC2 instances to use SES, then you'll need to configure the security group associated with your EC2 instances to enable communication with the SMTP endpoint. And just remember, port 25 is the default port to use for SMTP, but within AWS, EC2 throttles emails on that port. So in order to avoid throttling and avoid timeouts, there are two alternative ports that you can use instead, and they are port 587 or 2587. So do just remember those three ports. 25 is the default for SMTP, but within AWS, if you want to avoid timeouts, use 587 or 2587. Moving on to network packet inspection. Just remember, none of the following provide network packet inspection. So flow logs, which capture network flow for a VPC, subnet, or network interface, but they do not provide network packet inspection. They do not inspect the packets going through your network. And AWS WAF, so this protects applications from known exploits like SQL injection and cross-site scripting. But once again, it will not inspect network packets. We also have host-based firewalls like iptables and Windows Firewall. And iptables is included within the Linux operating system, and the same again for the Windows Firewall. That's the firewall included in the Windows operating system. And both of those will filter traffic to and from your instance based on port and protocol. But once again, they will not inspect network packets. So if you do want to provide network packet inspection, it's also called deep inspection or deep packet inspection, or IDS, IPS is another similar functionality. So if you do want to provide that kind of solution, you're going to need to use third-party software. And there are two different ways to approach this. Firstly, you could install the third-party software on your EC2 instance and manage it yourself. Alternatively, and this is much easier, you can search the AWS Marketplace and see what is on offer there. And the three main vendors to look out for are AlertLogic, Trend Micro, and McAfee. So if you go onto the AWS Marketplace, sometimes you can either just subscribe to a service or download an AMI to install an EC2 instance with everything already configured for you. Moving on to AD Federation with AWS. So if you want to allow your users to log into the AWS console using their Active Directory corporate credentials, you're going to need to set up AD Federation. And the first thing you need to do is to configure a two-way trust. So this just means that within AWS, ADFS or Active Directory Federation Services is going to be trusted as the identity provider. And then within ADFS, you need to configure a relying party trust with AWS as the relying party. So this just means that AWS is configured to trust ADFS to provide user identities, whereas within ADFS, it's trusting AWS to consume user identities. And ADFS simply acts as an identity broker between the Active Directory domain and AWS. And the user sign-in goes like this. First of all, the user logs into the sign-in web page using their Active Directory username and password. Then in the second step, ADFS authenticates the user against the Active Directory domain. In the third step, once the user is authenticated, ADFS sends back an authentication response in the form of a SAML token. Then in the fourth step, the user's browser sends the SAML token to the AWS sign-in endpoint. Then in step 5, the AWS sign-in endpoint calls the Assume Role with SAML API to request temporary credentials to the AWS console. Then finally, in step 6, the AWS sign-in endpoint redirects the user to the AWS console. So from the user perspective, their session is redirected seamlessly and they only need to log in once. So basically, you only need to remember it at a high level. You don't need to understand how it works at a low level. So just remember, the user authenticates initially with ADFS and AD. They then receive the SAML token, which is exchanged with the AWS sign-in endpoint for temporary credentials to the AWS console. And it uses the STS Assume Role with SAML API to give the user the permissions they need within the console. The user is automatically redirected to the console, and there is no need to create duplicate accounts within AWS. And finally, just remember, this is all made possible by the two-way trust, and ADFS is the trusted identity provider, whereas AWS is the trusted relying party. So moving on to AWS Artifact. Artifact is a central resource for compliance and security related information. It allows you to download copies of the compliance and security documents, and you can use these documents to demonstrate AWS compliance to various industry standards to your regulators. So it covers widely used standards like PCI DSS, ISO 27001, and it also has details of loads of other standards around pharmaceuticals, healthcare, finance and security, etc. And you can also use these documents to evaluate your own cloud architecture and internal processes. So that is the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.